Okay, so students, good evening. How are you? So the students who are in the online, am I audible? Please confirm it. Okay. So now it is a time to move forward. All of you wear masks. One more variant is coming, it seems. You know? Huh? What is that? One more is coming, it seems. XE. So XE means it is one of the global name in Oracle 11G. So different variants will come. So be secure by yourself and try to move forward. Okay, now we'll start with what is the use of constructors? Rocky, right, start. What is the use of constructors? To initialize the object. How many types of constructors are there? Two types. One is default, parameterized. One is default and parameterized. Very good. Can I write both the constructors at a time in a class? No, we cannot write. How many constructors we can write? One constructor we can write at a time, but it is going to contain default plus parameterized, but it should be initialized with the parameters with default values. Okay, default parameter mechanism, I need to go for it. Okay, so now it is a time to see. And I said yesterday, what is the name of the constructor? What is the name of the constructor? DEF underscore init underscore of self, list of formal parameters. Have you heard about underscore init dot py? Starting, I said. Functions. Don't open the notes. Keep the notes there. In packages. To make a folder as a package, that folder must contain one empty file. What is that empty file? Underscore init underscore dot py. That is one empty file that will initialize that folder as a package. Okay, na? Shall I move forward? Yes. Now it is the time to see. Today I am going for one concept called what? Destructors. Actually, if I tell to student, need not worry about the destructor. If I say these things, student can't understand. Destructors in Python. If I write this statement, if I say, I'm going to discuss almost 1 hour 40 minutes. If I say that this is one of the useless topic, if I say, you try to leave this topic, if I say, student will understand misunderstanding. So sir want to escape, that's why he is not teaching. And I will teach completely today. You will say, sir, it is not at all necessary, you will say. At the end, you will say that only. Because I am going to show programmatical in the class. So today, which I am explaining, 1 hour 40 minutes, is just waste. But if I say, can I skip this topic? If I say, you will say, no, you will say. Or some people will say yes, or some people will think in the mind. What? Sir want to escape, that's why you want to say. Because always escaping people are more, but I never. I am in front to discuss anything into you. Okay, anyhow, you see once, I'll discuss completely and you will say at the end of the class, is it useful to write or not useful to write? Okay, right. And right. Yes, ma, Rocky, that only I am saying. So why it is waste? So I need to know, sir. Okay, definitely. That's what I am going to start. Right now, Senapati, I'll tell you. Okay. That also I will cover. Last 10 to 15 minutes, I'll go for object. Last 10 to 15 minutes, I'll go for object. It's very easy because almost we discussed that. So definitely, Brahmani, How to open the student.data file in command prompt? Type. You said type. Type student.data. Type student.data. You are practicing files, huh? So you practice the topic whenever I discuss in the class. If you practice after completion of it, you will get 101 doubts. So you practice immediately when the topic is completed today. Practice immediately. So you will get it. Okay, finished now? Okay. Now why you got this doubt, ma'am? Fine. Yes, ma'am. Ibrahim, I'll tell you that. Don't worry. Let me start the destructors in Python. I'll tell you that also. Not an issue. We'll go for it. I'll go for it. Shall I move forward? Yeah. Now, why do you use constructor? To initialize the object. Similarly, why should I use destructor? To destroy the object memory space. To destroy the object memory space. Very carefully listen and you will understand within minutes. So I will write few points about this destructor, or I will show you some document for you. Here I am writing the name of the constructor is def underscore init self, that everything. The name of the destructor is def underscore del of what? Self. No more formal parameters. This is the definition of destructor. This is the definition of destructor. This destructor, I am telling to you, no need to write. Because who is going to take care about destructing the objects and collecting the unused memory space and all those things? Garbage collector will take care. We discussed in the beginning. During the simple feature explanation, I said destructor. Sorry, garbage collector. That time I shown this point also to you. A garbage collector is one of the Python background program which is running behind of every Python program, which eliminates what? Unused memory space. Which eliminates which memory space? Unused memory space will be removed. So how this is going to be done? I'm going to enter into the discussion. So how the destructor is, how the garbage collector is running internally, in this case you are going to understand. Two things you are understanding. One is a destructor mechanism. One more is a garbage collector mechanism. Two things you are understanding in the class. Fine. So as we have seen it in the previous session, if we come back, here I am going to say, in our class, there is a class, features. There is a classes and objects. Under that structure of the class, if you see class structure, inside of it, already we discussed in the class about data members, finished, types of methods, types of constructors. Today we are coming to where? Destructor. Okay. What is the name of the destructor? Def underscore def. Right. This destructor internally called by garbage collector. Constructors are called by PVM. Constructor is internally invoked by, executed by PVM. But your destructor is internally executed by garbage collector. And dear students, you need not to define your own function, because garbage collector already contains what? Del function on its own. Garbage collector already contains del function on its own. You need not to write. We need not to write our own destructor, because garbage collector already contains inbuilt del function in itself. Even if we write it, there is no special impact on it. Let us go to the program now. I'm going to show you the discussion now, programmatically directly. I'm going to give you the clarity. Class, this program or I am going to give you DEST destructor example 1.py. Class EMP, class employee, and I am taking their DEF underscore init underscore of self underscore of self dot envo is equal to some 10, self dot ename is equal to something like rs enough. This is the data, and I am writing there print of what is this. I am from which one? Constructor. I am from constructor. Okay, so I'm going to write it. I am from constructor. Well, now I'm going to write one more type of function, def underscore del del underscore of what? Self. That's it. I'm going to write it as statement. I am saying that inside the class there is no need to write what? Destructor from our side. Why? Automatically garbage collector is containing its own destructor inside of it. There is a special advantage for us. Okay, del I am writing gc calls which function? Destructor. dc calls it's a dc calls destructor for deallocating memory space, deallocating unused memory space. I am writing deallocating unused memory space. Well, now I am going to write it. Coming to the main program, I am going to say EO1 is equal to what? Employee. Which object is created? One employee object is created. Because of this, which one is calling? Constructor is calling. Are you following? Once if I say this, generally we felt up to yesterday, just close this part. I will give a comment here. Try to understand immediately. I just wrote like this. Try to execute and just observe it. What is happening? Go to the location of yours. Say 4 p.m. Say oops here. Inside of it, talk destructors. Right? Destructors. Inside of it, try to save this first program. EMPX1. Go to the command prompt. E:/cd. I'll say Python. Say 4 p.m. So say this here. Oops here. Destructor here. I'm taking. Let us start this. Py. See that example. Here what is happening? Constructor executed. Object is initialized. That means once you look at this program, we used to see only the data. You want? I will print this data once more. Print. I just say \t format. Slowly you will understand. Nothing to worry about this for a few minutes. envo, comma, self dot what? ename. Self dot ename. Just try to execute. So I got the output here. Okay. Now, okay, we understand that program is completed. That only we understand so far. How do you know that program is completed? Once the PVM comes to line number 14, line number 14 is nothing but end of our program or not? Listen, all of you listen carefully. Vamsi, listen carefully. Self is mandatory or not? Where self is mandatory or not, you are asking? Which line you are asking self is mandatory or not? Regarding the self concept, already we thoroughly explained. Self mandatory or not, where are you saying, ma? Which line you are saying? No, which line you are saying? Why you got the doubt first of all? Third line. Self mandatory or not? Then I already explained yesterday. Already explained. Fine. So coming to the point of it. Next, already explained that kind of things. Please take care. Read the notes. Now, once this line number 13 is over, line number 14, when we come back, program execution is finished. Once program execution is finished, separately you need not write a special code to eliminate the unused memory space. Who is automatically calling? Garbage collector will call what function? Underscore underscore del function. Garbage collector contains its own destructor to deallocate object's memory space. Let us remove. Just remove. Now see what is happening. Just to see what is happening. The moment when line number 13 is over, the line number 113 is executing, control goes to where? Class, and looking for what? Init. Executed. Who completed? PVM. Next, the moment when program is over, PVM job is over. Next, whose job is left out? To clean up the objects which are allocated for this program. Garbage collector will come into picture. Garbage collector will call which function? Del function. Actually, I just wrote del function. Since I wrote garbage collector will come to my class and will execute my own del function, and it will call its own del function also. In that del function, PSF people has written the operating system code to deallocate the memory space. Are you following me? So execute this code, try to answer this and see what is happening. After my program execution is over, what is calling? GC calling. GC calls what? Destructor for deallocating the memory space. Now I am removing this. I am removing this code. Dear students, I am removing this code. Remove this code and execute. Am I losing anything here? Am I losing any special thing here? No. Whether I am writing or not writing, garbage collector is calling internally which function? Underscore underscore del of self function is calling. Still, I will give a lot of examples. Let me move forward. Slowly try to understand. Okay. Now I am writing here. Even if I write it, there is no special impact on my application development. Only thing is I can convince the people that garbage collector is internally calling which function? Underscore del underscore of self. Understand? Okay. Let me go to the next example. Carefully try to understand. I take destructor example 2.py. One more example I am giving. EO1 is equal to employee 1. EO2 is equal to employee. I am taking like this. EO2 is equal to employee. How many objects are created? 2 objects are created. How many times constructor is calling? How many times? 1 time or 2 times? 2 times it is calling. 2 times object need to be initialized or not? Yes. Okay. 2 different objects are created with the same ID or different ID? Same ID or different ID? Different ID. I shown already in the class yesterday. ID of self I set. Then. Okay. When it comes to line number 14, my program execution is over. How many objects has to be removed from the program? Program is over. Totally my program came to line number 14. How many objects you created in our program? 2. How many objects has to be removed? 2. So who will remove the 2 objects automatically? So garbage collector is internally calling what? Destructor. What is the name of the destructor? Underscore del underscore of self. So who will call underscore del? Garbage collector. Who will call the constructor? PVM. So when the line number 13 is over, PVM job is over. When it comes to line number 14, whose job is remaining? Garbage collector job is remaining. To deallocate that EO1, EO2, whatever memory space is there, where my program is completed, it has to deallocate the memory space and give to the operating system. I borrowed two objects memory space from you. You are an operating system. I borrowed from you. So after my work is completed, I have to give the memory space back to you or not? Who will give the memory space back to you? Destructor will do. That is garbage collector internally calls. So how many times garbage collector is calling del function? 2 times, because two objects are created, two separate memory spaces there. 2 times garbage collector is calling. Let us see this. Execute this code. I will save my code. I will save this code. Execute. This part you execute. Go to the location once. I'm going to say here, your location, please. There I will go, whoops, under that destructor, save this code and try to execute. So see that 2.py, see that 2 times 2 objects are created. 2 times destructor is calling or not? Fine. Now if you want, I'll go for one more small example. Another example I will go for it. So people will ask a question, when the destructor will be called? Tell me, when the destructor will be called? Destructor will be called in 2 situations. Keep in mind. You are understanding one situation. Which is situation? When the program is getting completed, at the end of the program completion, the destructor will clean up all my resources related to the memory space. Given to whom? Operating system. So that's why this garbage collector is calling which function? Underscore del function. That is a destructor is calling. So if you want one more object I will create, EO3 object I will create. Second time I am saying, which one I am going to say? Employee. Which one? Employee. I am going to take employee. How many objects I am going to create? 3 objects. How many times constructor is calling? 3 times. Okay. Well, now I am going to say, if I am just closing my program, how many times destructor is calling? 3 times. Who is calling destructor? Garbage collector. So at which line garbage collector is coming into picture? Line number 15. Line number 15. Once let me execute. After 2 minutes, I'll show you this point what I want to what I am interested in. What I am interested in. I'll go to this and I'll save my program. Destructor example 3.py. 3.py. So coming to this point, I'm going to say 3.py. So I'm getting 3 times destructor is garbage collector is calling destructor. Well, let's move to the further. Suppose this is the one I am taking some small a small event I want to show you. Time dot sleep off some 10 seconds. Time dot sleep of 10 seconds. Still it is a Python statement. Still it is a Python statement. I will say import what? Time. Tell me, after my program execution is completed, my objects are about to be collected by garbage collector. My PVM is still under execution. He is sleeping for how many seconds? 10 seconds. Once the 10 seconds is over, whose job is over? PVM job is over. That means program is completed. Who will come into picture? Garbage collector is calling. Which function will call? Underscore del function. Let us execute once and see that this program you see. So it is waiting. 10 seconds waiting. PVM is under sleeping. And now when 10 seconds over, 3 times garbage collector is calling del function. Are you getting my point? That means whether I write a del function or not, compulsory in every Python program, who will call what? Garbage collector will call its a destructor to deallocate the object's memory space. Did you understand? If any interviewer is asking, how do you know that destructor is calling this del function? You have to show this example. Shall I move forward? So first case is when the destructor is calling del function when the program is completed. That is first case. Second case I am going to show. Shall I? Right. At the end of the program, at the end of the program, my destructor is calling. Now I'm writing, if I write everything in one place, you want for practicing purpose, destructor example 4.py. So here I'm going to say, how many objects are created? How many objects are created? Okay. My object E1 is used. Constructor is calling. Line number 13, constructor is calling immediately. When line number 14 is there, I am no longer interested to use EO1. I am not interested to maintain EO1. Actually, EO1, EO2, EO3 will be collected at what line? 16th line. But here, when EO1 object is created, I initialized my object. I performed some operation also. I am no longer interested to maintain what? EO1. That means when an object is initialized, after doing some operation, I want to delete. Explicitly, I want to call that garbage collector. I say DEL. What is that? DEL. Where I taught DEL? In the list time only. Inner list removing, inner list elements, slice based removal, index based removal, pop function, pop of index, remove of index, remove of element, pop of index, del of index. It is a generalized function. Removing based on what? Index as well as slicing. It can remove even object also. DEL. What is that? EO1. What is the meaning of it? I am explicitly deleting the memory space of what? EO1. When I am deleting the memory space of EO1 means what? Explicitly I am inviting which one? We explicitly I am inviting garbage collector to deallocate the memory space of what? EO1. Are you able to follow? Now tell me, execute. What is happening? Tell me, this is called a destructor example 4.py. Destructor example 4.py. Go to the location. I'm going to saying here 4 p.m. So go to this place, destructor. I'll save this code. So when line number 14 is there, immediately straightforward. At this point of time, GC calls which function? Underscore underscore del underscore what? Self. Shall we observe it? So the line number 14 is implicitly calling or explicitly I am making it to call? Explicitly we are making it to call. This is nothing but how many ways are there to call the garbage collector? 2 ways. One is automatic garbage collection calling. One more is forcibly making the garbage collector to call. Did you understand? Okay. Now see that line number 14, who is removing? EO1. One time garbage collector is calling. Which function? Del function. Coming to EO2 and EO3. What is EO2 and EO3? Another objects created. And when they are automatically collected, when it comes to line number 17. So here also how many times garbage collector is calling? 2 times. How many times? 3 times. Line number 14 1 time. Line number 17 it comes 2 times it is calling for EO2 and EO3. EO2 and EO3. Execute. Now see that 3 na 4. 3 na 4 example. 4.py. See that after the first one is over, after the first object is over, what I am removing, garbage collector called or not? 1 time. And 2 times this is calling, that is nothing but what? Totally how many times? Earlier called how many times? 3 times. But at what time? Ending of the program. But it is calling whenever I need, I can invite the garbage collector. Did you understand? How many ways are there to call my garbage collector? One is automatically, implicitly at the end of program execution. That is the first one. Second one, forcefully when the object is explicitly deleting by using which function? Del function. By using del function. Other function also I want to remove. Come on. Other function also I want to remove. DEL. What is this? EO2. EO2. See that I'm getting, see that object is initializing, destructor. Second object initializing, destructor. Third object initializing, destructor. How many times you are calling? 3 times del function I am calling. 3 times del function is calling. 3 times your function is calling here. So here need not to call DEL. DEO3 need not to call. Why? Implicitly by default calling. Why should I waste my statement by calling like that? Understandable, students. So here 2 ways are there to call this. So first object GC, second object GC, third object GC. Let's go back. Let us go back. This is one scenario. This is one scenario. So I'm writing here GC calls. What happens? GC calls like this. This is called one more scenario here. Let me talk about one more example. One more example. Here I am writing others. Coming to this. Listen all the examples. First of all, Ravindra, Rocky. Remember all the things. Remember all the things. Rocky, remember ma. Remember this. You can delete all the things. No issue at all. Right. What is GC? Ganesh Verma is asking what is GC. Ganesh Verma is asking what is GC. See that what is GC? Garbage collector. So we are saying GC, garbage collector. Ganesh Verma, garbage collector. Fine. Coming to the next destructor example, fine. How many objects are created? One object is created. Next I'm saying EO2 is equal to EO1. Understand? What is that copy? Deep copy. Very good. What is this one? Deep copy mechanism. Yes. How many objects are created? 2 objects with one memory, 2 memories. One memory only. Deep copy maintains same memory space. Yes. Right. Fine, ma. Vamshi, what is that, ma? Why are you ask Verma? Okay. So, let it be. So, coming to the point back, I'm going to say deep copy. Now, here, Vamshi, let it be, ma. Let it be. They will ask the doubts. I will clarify. So, you be with me. You don't interfere to each other. You be connect to me. Right? Come on to the point of it. So, coming to the next point, EO1. Which copy this is? Deep copy. So in the deep copy, you can imagine the picture. You can imagine the picture here like this. So I'm going to write it. EO1 is an object which is containing 2 values. Number is equal to, name is equal to. Some address will be there or not? Some address will be there. What is it? 1, 2, 3. First time this is created. Second time, what is that? EO2 will take the same address or different address? Same address or different address? That means to the same address, how many objects are pointing? 2 objects are pointing. So space is one only, but 2 objects are there. Already this is explained. Now I am going to say DEL EO1. Will the garbage collector will call the destructor or not? Will the garbage collector will call the destructor or not? That is my question. Will it call or not? When the garbage collector will call, a garbage collector will call when there is nobody pointing to that memory space. When somebody will take away your mobile, without telling to you, suppose nobody is pointing to my mobile, it is just left empty. Somebody will take out our mobile or not? If nobody is referencing to that, if nobody is pointing to that, it is eligible to be collected by what? Garbage collector. So most of the people will feel del EO1, everybody will feel that it is calling the Del function. GC calls the destructor, but it will not call. Why? Because when EO1 you are deleting, who is pointing to that memory space? EO2. Myself and my friend is pointing to that mobile. I went out for some relax. My friend is pointing now. Nobody can touch. Myself and my friend went out. Definitely it is eligible to be collected by garbage collector. Did you understand the theme of it? Yeah. Come on to this point. Now I am going to say DEL. What is that? EO1. DEL EO1. Will the garbage collector will call? No. I am writing here. GC will not call which function? Underscore what? Del of what? Self. Del of self will not point. GC will not call underscore del of self. Because, why? Because why it is not calling? Who is pointing? EO2 points to the same object. EO2 points to that object, to the object. Right? Come on. You just see this now. Now, DEL EO1. Next, I'm not calling that. Next, what is happening now? Time dot DEL. Next is what is happening there. When it is happening, garbage collector is not coming. Next, I am going to call what? EO2 I am calling. What will happen? That time it will be calling it. Why? Because no more memory space is pointing. No more objects are still pointing to that memory space. So because of 2 times del, how many times garbage collector is calling? Because of 2 times del, how many times this garbage collector is pointing? Only 1 time. Why only 1 time? Because only one object is there. Deep copy concept is followed. Only one object is followed. So I will write here. Here GC will point to, GC will call. Here I can write it. I am writing here this statement. At this point of time, who will call? GC will call. Which one? Del. Because I can write down. Because say this. Because EO2 is nowhere. EO2 is and nowhere. And nobody, no object pointing to no object points to objects points to memory space what is allocated. Did you understand this? Save this quote. Here I am writing, if you are interested, print no longer interested. I am giving one small, no longer interested to maintain EO1 memory space. There I am going to say time dot sleep of what? 10 seconds. Here again I will write it. No longer interested to maintain which object? EO2. That time what will happen? Garbage collector will come into picture. Are you following? Here EO1, I am going to say what here? DEL. Here you say DEL. After this time, no longer interested to maintain. After the sleep, you say DEL. Nobody will call it. No garbage collector is calling. Here I am going to say no longer interested to maintain EO2. Sleep. Immediately you are saying what? Del. And immediately what will happen? Garbage collector will call. I hope you are following that. If you are not getting sleep and all these things, I will remove. So because of the sleep word, you will understand this internal process, how it is executing, I feel. So let us execute 5.py. 5 or 4? Okay, about to save. About to save it. Okay, yes. So let us, why it is going to show all these things daily this. So it is this place under this destructor, save this code 5. Coming to the point of it, PY 5, you see that no longer interested to maintain EO1 memory space, but garbage collector is not calling del function. See that no longer interested to maintain EO2. This time garbage collector is calling because only one object created, two objects are pointing there. It is nothing but which type of copy? Deep copy concept is pointing there. So GC calls destructor for deallocating. So in this way, I will take up one more kind of thing. EO3 is equal to what? EO2 I am saying. EO2 I am saying. Now tell me, this is also called which one? Which copy this is? Deep copy. Deep copy. No longer I'm interested to maintain what object? EO1. Next is called what here, time dot sleep and a DL EO1, DL EO2 also. Here also GC will not call DL off. Right. Next I'm going to say, last and final I'm going to say here, no longer maintaining interested to maintain EO3. I am not at all calling anything. If I like it, I can remove. Automatically calling or not? No need to say what? Del of what? EO3. I am removing DEL L1, DEN EO2. I need not to go for calling DEL EO3. Automatically getting calling only. Let us execute this. So no garbage collector is calling the del function. EO2 time also nothing is calling. Last time only it is calling. Right? So EO2, no more memory space elimination. Last is called what? EO3 object is coming. That time garbage collector is calling automatically. At the end of the program that will be calling or not? It is as good as similar to what? Del also. So finally, what do you understand? Is it necessary to write the del? Is it necessary to write the destructor in our program or not? That you finally tell me. Necessary or not necessary? Not at all necessary. If at all anybody asks you, is it necessary to write default destructor or not? One can show this type of code. So finally, whether in all these programs, I can happily remove this underscore del mechanism. So where it is required to write it, if any kind of programming language does not provide garbage collection kind of modules like C language, like C++, there we need to write. Destructor is there in C++ also. That time you need to write the coding for destructor. But the Python programming like here, there is no need to write destructor concept. Actually, I don't teach destructor up to last 2 years. Last 2 years onwards, I am trying to teach this because students will ask our destructor, what will be that? If I say it is not necessary to write it because they will think in different way. That's why I used to explain from the last 2 years onwards. Is it really necessary or not necessary? Not necessary. Why? Garbage collector contains by default its own garbage collector. No need to write from the programmer side any such type of destructor. So ultimately, who will call destructor? A garbage collector. Who will call constructor? PVM. What is the purpose of constructor? Initializing the object. What is the purpose of destructor of garbage collector? To deallocate the memory space, to clean up the resources of my program. Whatever I borrowed the memory space, that I will give to the operating system. Such a type of internal code is called a garbage collector. Garbage collector internally contains its own destructor is there. Did you understand? Yes. How many ways are there to invoke? My garbage collector? 2 ways. One is implicit and one more is forcibly by using what? Del operator or del function. Okay, right. So students who are in the class, did you understand, students? Did you understand? Yes. Now, One more point I would like to show you in the class. One more point is, there is, sir, how can you prove that GC contains a destructor by default? That is also an important term. Fine. For that student, Varma, listen. Don't concentrate on your things. Listen what I am explaining also. Okay? Listen. Varma, listen ma. Now, I am going to say, how do you prove that GC contains a destructor is there or not? I need to prove that. Yeah. For that, there is a GC stands for garbage collector. Otherwise, Ganesh Verma will ask what is GC. GC stands for, it is called one predefined module. It is called one predefined module. Predefined module. Yeah. It is a predefined module. This contains, actually this module also not necessary for the programmer. Not at all necessary. Because almost I came to the destructor, which I wasted some time already. I want to speak about this also. GC related to what? Garbage collection related module. Is the garbage collector is by default running or not running? By default running to every Python program. So how can you prove that also? I am going to give you some small clarity. In the GC module, there is one module is there, is enable. Is enable. The name itself says, listen, Ranjan, all of you, listen ma. Listen. Is enable. The name itself says, any function starts with is subset, is superset, is disjoint, like that, it is going to return either true or false. So, it is going to return true when it is enabled, when it is running. If it is not running, it is going to give you what? False. Shall I check it out? It is the function present in which module? GC module. How do you call it? GC dot enable. Is enable. Is enable. Okay. Is enabled. Enabled. I will check it out. Is enabled. I will go to my program. Any program you go. I'm going to take here one small example scenario, or beginning program only you go. Beginning program only you go here. This case you see beginning level program, or any program which you have written so far, anything you take it. Here I am just taking main program. Printer is garbage collector. Garbage collector is garbage collector running. Is garbage collector running, comma, GC dot is enabled. Is enabled is my function. And is it enabled? Is it switch on by default? That is the meaning. I need to import GC or not? Import what? GC. Import GC. It's an important, guys. GC. So it is going to say, is garbage collector running? What is the answer is coming, ma? In the beginning day only, I told you, behind of every Python program, one garbage collector is running, I said, which is used to eliminate unused memory space, and it improves the performance of Python based applications. Okay, let us execute it. Let us execute it and see that what is happening. Say, I will go to this place under whoops only. Under whoops only, I will say GC. I will keep GC. Under this, I just want to save it. Come out of that. CD, come out of it. CD GC. Now you execute PY. Say this one. You see what is happening here. Is garbage collector is running? Beginning. Beginning. True. Is GC running? True. Last one you see. GC called. GC calls what, ma? Destructor. For deallocating. That means, am I making it to run explicitly? No. Behind of every Python program, is it running or not? Yes. How can I find that it is running or not? By using a GC module, there is a function name called what? Is enabled. Is enabled returns true when it is running. Go. Similarly, I will go to this place. After the object is created, do you know what I am doing, student? GC dot, there is a function called disable. There is a function called what? Disable. Disable means what? Switch off the lights. Switch off the lights. That means telling to GC, don't run. GC, don't run means what is the meaning? It completely stops executing or not? That is the meaning of it or not? Whenever you are calling this in the Python current versions, of course from 3.8 version onwards, whenever you say disable, because of this facility, if you use it by feeling that garbage collector is disabling, when you say disable, definitely people will feel garbage collector stops running. It was up to there before 3.8. It stops running. Because of stops running garbage collector, how many problems will come into picture? You think about it. If I use by mistake in my real-time projects about 3.8 prior means before, if I say one time GC dot disable, in many, the total entire project of Python, no garbage collector will work. From 3.8 onwards, even though you call what? Disable. When it comes to next line, automatically it will be enabled. In the sense, for you, it will show you. That also let me show you. I am writing, after disable, what is my garbage collector actually printed? What is this actually will print? Definitely false will print. When it print false, if we feel that false means what? Not running. Not running means what should not call? What should not call? GC, okay. GC is calling which function, ma? Del function. GC is calling which function? Whenever I say what? Disable, what is an answer is coming? False means running or not running? We feel it is not running, but internally I am saying to you it is running. How? It is printing which message? Del function is calling. That indicates what? Is our statement of disable having a meaning or not? First of all, are you understanding my English? Whenever I say disable, what is the meaning? A person is walking, all of a sudden legs break, disabled. Will he walk? Will he walk? No. No means what? Second time false. Right or not? So I am going to run what? Line number 13. What is an answer? True. Next time what is created? Object. Next time what I said? Disabled. Disabled means who has to stop? Garbage collector has to stop. Stop. Assume for a few minutes, stop. What is an answer is coming? False. False means what is not running? Yes. Garbage collector is not running means line number 17 comes, my program is over. That means garbage collector should not call what? Del function. If it is calling means it is running. That means even though you disabled, it is not at all affecting with that sentence. It is actively running. What? Garbage collector. See that proof? See that proof? All of you should carefully understand. See that? Are you getting? Not getting. You will not get. You are very, very powerful student. You are. Time dot. Sleep off 10 seconds. First of all, you understand. Import time. Import what? Time. Import time. Execute. See that. Garbage collector is running is false. Within 10 seconds. If it is false, del function should not call, but it will call. It will call now. See, calling or not. That means, is your disable function will have a meaning or not? In the present version, there is no meaning. There is no. Why? Because this was having an effect before 3.8. Because of 3.8 disabling, the total Python project is becoming heavyweight and unable to run because of vast amount of memory space utilization is poor. In 3.8, the disable function is disabled. You call it, let the user feels that it is disabled, but we will run it internally. Are you able to understand? So tell me, even though I disabled, is the garbage collector is running or not? Yes. How do you enable the constructor? GC constructor once again. GC dot which function? Enable. GC dot enable. Again I am going to enable. What is the answer here? What are the three functions present in GC? Is disabled, enable, disable. Disable will makes the garbage collectors to stop running. Enable will makes the garbage collector to resume its execution. Even though we say disable, is it really disabling? No. No. How do you prove that? I have shown you the proof. Okay. Even if I say this part, you see what is happening. Even if you say false, what is happening? You see that now. What is happening? First time true. Second time false. I enabled it is called what? True. Now it is true means what? Enabling running. It will call again. Whether it is enabled or disabled, definitely garbage collector will call its default, its destructor. You tell me, garbage collector is continuously running or it is affecting the meaning of disable? There is no affecting the question of disable function. So if any questions are coming on garbage collector, what questions will come? Suppose if I disable my garbage collector with the disable function of GC, do you feel that the destructor calls or not? They will ask you. What is your answer? Yes, it will compulsory call. You will question, is it really? Yes, 100%. Open your laptop, show the program. Even though he is under the impression that it is not running, you show the laptop and run it. Will you understand? I am showing practical. If anybody asks this question very firmly, don't get confused because I am showing that result. I disabled it. Still, even though I disabled it, it is getting calling. There is no effect of which function? Disable function. So what is the GC? Predefined module. Contains how many functions? Enable, disable, is enabled. Is enabled returns true when it is under running. Is enabled gives false when it is not under running. When it is not under running, I should not say that because it is always under running from 3.8 onwards. But they continued that module even now in these versions also. Actually, that version, that module has to be removed because definitely end user, definitely programmer may be interested to use that GC module to disable or not. Even though I disabled, my garbage collector is running or not? Yes. How do you prove that, sir? This is a proof of it. So, even though how that I was written it, I was disabled it, and I was removed earlier one, it is calling this. Fine. So I will say once again here, what is this now? GC dot what again? Disable. Disable I will say multiple times. Is it running? Is it still running? Enabling, disabling. I'll say this is going to be called what? False. Now still I disabled it. It is going to happily call. True, false, false, true. First time true by default, false, true, false. Now it is disable. It indicates that garbage collector should not call, but it is calling or not. That means, is our disable function will have the meaning or not? No meaning, and it is not at all affecting to its running process. Okay, Ganesh Verma, are you okay? Satisfied with my answer? Satisfied with my answer? Ganesh Verma, are you there? Coming to the point back, here I am going to say, oops, here there is a destructor concept is there. I just want to show you the small documentation for you. Look at that, students, all of you. We know that garbage collector is one of the, come on, read out. inbuilt Python program which is running behind of every Python program and whose role is to collect unused memory space and improves the performance of Python based applications. The same wording I was written in the beginning of the features of Python only, simple. Explained or not? Yes. Next student, every garbage collector program is internally calling which program? Yes. The destructor name in Python is, come on, def underscore underscore del underscore underscore of self. Okay. The destructor always called by garbage collector when the program execution is completed. For what? Deallocating memory space. Whereas, constructor called by whom? PVM. Implicitly, when the object is created for initializing the object. Okay, we have programming conditions. We have programming conditions to make the garbage collector to call. We already told you two things. One more also I will show you. What is that? To make the garbage collector, we have programming conditions to make a garbage collector to call destructor function. One is make the object reference as what? None. None means what? Nullify. Nullify. Kill that object. Kill. How do you kill that object? By making object is equal to none. I will show you that also. Coming to next, delete the object by using what? Del. Del. What is that? Automatic collection of what? Automatic running of. These are called what? Forcibly calling the garbage collector. Forcefully calling the garbage collector. So A and B approaches. A and B approaches. I will write it. When the program execution is completed. When the program execution is completed. Execution is completed. Completed. Come on. GC calls its own. GC calls its own. Which constructor? We are destructor. GC call its own destructor to deallocate the memory space of what? Objects in the program. Objects present in the program. Present in program. Right? This is automatic garbage collection running. This is called automatically. What is this? GC running. Automatically garbage collection is running. And we have two programmatic conditions. We have two programmatic conditions for calling GC forcefully. What is that? To make forcefully and to make, what is it? And to make garbage collector to call what? Destructor function. What is the first one? Make the object as what? None and use what already? Del. So let me show you syntax also. Below to that syntax I will show you. What is the syntax? Del underscore del underscore del of what? Self. So let me show you this object is equal to none. Let us go to this object 3. Object 4 I will go for it. Object 4. Okay. Take it. Go to the new program. Python program. Here you say dst example 6.py. Say this EO1 del. Here I am going to write it. Which one I am writing, ma? EO1 is equal to what? None. What is a none? None data type. Calls. GC calls which one? Del. Next again I will do what? EO2 is equal to what again? Is equal to none. GC calls which function? Self. So EO3 is equal to none, not necessary to write it. Why? By default, you need not to call EO3. You need not to call EO3. You need not to call you need not to say EO3 is equal to none. Neither to write EO3 is equal to none nor del. Automatically it is getting calling. Okay. So this is called what? Forcefully calling. Forcefully calling, this is. Forcefully calling. Calling what? GC. Forcefully calling GC. Same thing, forcefully calling GC here also. Here also forcefully calling. Okay. Here what is happening? What is happening? GC calls automatically calling. Automatically calling GC. Automatically calling GC. Let us execute this also. Let us execute this also. Say destructors. Go to the destructor once. CD, come out of that. CD destructors. Okay. Py. 6.py. See that, students? Are you getting my point? So none I said. Even though if I say none, they are getting calling. If you want, I can change. This is the previous output you have seen now. I will show you this object you created. This object you created. 2 times I want to call the 2 objects I want to remove at a time. 2 objects I want to remove at a time. See that 2 times object destructor is calling or not? Here. So how automatically? That is the biggest question, Ganesh Verma. So coming to the point of it, this is called what? Automatically. How automatically is asking? When the program is over, it is calling means it is automatically or not? So need to understand, garbage. This is called what? Once the program is getting over 18th line, is there any more statement to execute the Python program? Is there any call to the garbage collector? Is there any del function? Is there any is equal to none? It is called what? Automatic. That is called automatic. Fine. So coming to the point of it, here, last one you see, last one is automatically calling GC. Neither a del is there, nor object is equal to none is there. Nothing, no more 2 conditions are there. That is the final condition is automatically calling. Are you understanding? So out of these things, is there any useful of writing this del function? No. Is there any use of writing our own del function in the program? Not necessary. So out of it, writing constructors is necessary or not necessary? Constructors is necessary, but writing destructors is not at all necessary, because every GC contains its own, every garbage collector contains its own destructor. It will deallocate the memory space automatically. Is it clear? Fine. Moreover, this is one thing you must remember it. This is one thing you must remember, students. I'll say this point here. In this place, GC module is also there. GC module is also there. They also try to take care about this. There also, maybe somewhere else. Destructor concept is also might be there. Destructors in Python. Okay. So I will just take up GC. So anywhere else, this part I will just show you. Of course, this is already you seen that GC and time, even in this place also. GC contains how many modules? GC contains how many functions here? 2 functions are available. One is called what? Is enabled. Next is called what? Enable function. Next is what? Disable function. This is one of the unused module nowadays. Right? And one more is unused concept in programming is destructor. I hope you are understanding about both of them, and don't expect that GC we will use it in our programming as practices. We don't use that in the programming practices. I hope, students, our concept of Destructors is clear for you. Our concept of destructors is clear. I hope so. So the time which is spent on this so far, I hope you are understanding this discussion. Fine. So finally, is it necessary to write destructor in our class? Is it necessary to write necessary or not necessary? Not at all necessary. So if I come to this place of this classes and objects, I'll open classes as structure once. Now just say one thing. If somebody asks you tomorrow, what is the definition of class? A perfect student will say definition of class is a class is a collection of data members, methods, constructor, destructor. And definitely when you say these many points, they will ask you what is the need of data members. Data members are used to store the data in the object. What type of data I can store? Specific data in the form of instance type. Common data in the form of class level data members. You know how to write and where to write. Now tell me, instance data members I can use in how many places? One is through object. One more is through methods. One more is through constructors. Where I used in constructors, look at. Where I used in constructors, you see. Here I am using, even in today's class also, inside the constructor I am using instance data members or not? Am I correct? Where I already specified inside the instance method. Where I already specified beginning example through object itself. How many ways? 3 ways. If I look at that, types of data members in the class, because this is all very, very important. Instance data members for storing which values? Instance data members must be specified in how many ways? Through what? Through next. Through what? Instance data members always available inside of known as object level data members. Can be accessed with respect to object name and then or we can access with respect to self. We can access it. I hope you are understanding that. Okay. Now, anyhow, this is class level data members you have seen. Inside the class definition and inside the class level method definition, you have already seen in the class. That is straightforward. Okay. Now I am going to give you the clarity on something like object concept also you are expecting. So what do you know about object? You tell me. Once you define a class, come on students, take care about all these things. Take care about all these things. So I'm going to say here, coming to this point, class you take it. Classes concept you take it in our class. The purpose of classes concept is to develop programmer defined data type and to develop any real-time application. The purpose of developing programmer defined data type is to store customized data and to perform various operations. Okay. To develop any programmer defined data type, we use which keyword? Every class name is acting as what? List, tuple, set. These are all called classes. Na? Today, what is my class? Class, student, human, employee. What they are? Classes like. Which classes? Programmer defined class names. So I have to create objects or not? Why to create an object? If I say only list, will it store the data there? No. L is equal to list of. S is equal to set of. D is equal to dict of. Then only I can store that object or not. What is that object? Used to store the data. What type of data? Depends on the class I designed it. Understanding? So, what is that object is? That object is nothing but a place where we can store the data always. How you can define an object? Instance of a class is called object. It is one of the technical word. Instance is nothing but allocating the memory space. Instance is nothing but allocating memory space for our data members as well as for our methods. So, any program you will start writing, first what will exist? Class. So, from the day one onwards, that only we started with. First program which I started with, student example 1, if I open, what is the first started with? This line I started with. Did you remember? What is it? Class. When class is there, no more memory space. Memory space is coming when we create what? Object creation. What is the definition of an object? Instance of a class is called object. Who are you? Instance of student class. Who am I? Instance of faculty class. So instance of a class is called object. What is the definition of class? A class is a collection of data members, methods, constructors, destructor. Or if you say collection of data members and methods, also clear. If you want to say more and more elegantly, you can say constructors and a destructor. When they ask questions on constructor, you must able to answer. When they ask destructor questions, you must able to answer. When you say more and more elegant answer, they will ask you questions on every part of it. So it's one thing good if you say all these things, but you must know everything in detail. Okay, now. So if we go to that place, go back to this place, I'll go to this and I'll show you one small object definition for you. Object concept I will show you. Classes, somewhere else, object, somewhere else maybe. Generally, very rare I will write a separate heading for that kind of things. Fine, let us go to that. I'll search for it. Object. So, object. Okay, it is there in some place. It is there. So, objects in Python, try to open it. Please read it. You only read it, you will understand. We define a class. Memory space not created for data members and methods. But whose memory space is created when we create an object? With respect to what name? Right. To do any data processing, it is mandatory to create. Any data you want to do, store and process something, definitely object is required or not? Okay. To create an object, there must exist what? Otherwise, we'll get what error? Name error. Suppose there is a class called ABC, which is not there. Can I create an object of ABC class? No. So what should create first? Class. What is the definition of class? Come on, start with. Instance of a class is called. What is meant by instance? Nothing but allocating sufficient memory space for data members and methods. What is the syntax for creating an object? Variable name is equal to class name of. L is equal to list of. Create an object of which class? Student. How do you write? SO is equal to student of. Create an object of employee. How do you create? EO is equal to what? Employee of. Already done only, na? Any difficulty? So, see that one more I am giving here. Differences between what? Classes and objects. Start. What is the definition of class? First one. A class is a collection of data members and methods. Academic table if you want. Anybody is having Python. If that question is coming, you will get full marks. A class is a collection of what? Data members and methods. What is the definition of object? Instance of a class is called object. When we define a class, memory space is not created for data members and methods, and it can be treated as a specification or model for what? Real-time application. Beginning only. A house plan is nothing but a specification. It is my plan of the house. When we create an object, we get the memory space for what? Data members and what? Methods. Third one, definition of a particular class exists how many times? Class student. Student class will exist one time only. Today, EO1 is equal to employee, EO2 is equal to employee, EO3 is equal to employee. Employee class will exist how many times? How many objects we are creating? 3 objects, 4 objects, any number of objects. See, with respect to one class definition, we can create. Okay. Next, when we develop any program with OOPS principles, class loaded first only once in main memory. EO1 is equal to employee. That employee class will be available once in main memory. That is the meaning. But EO1, EO2, EO3, EO4, EO5 will exist how many times? Many times. List class is there, na? How many times it is available? One time. L1, L2, L3, L4 are many times they are going to be available. When we create an object, after loading the class definition, what is this? When we create an object, when we create an object, we can create an object after loading the class definition. Without loading the class definition, that is without defining the class, we cannot create a object, because you will get what error? Name error. So when we create an object, we can create an object after loading the class definition. Otherwise we get name error. So for example, if we go to this place, I am writing here something like k is equal to KVR of. I'm just writing one sentence. I am writing. Go to the last place. Error is coming or not? What is that error? It is not at all there. How can you create that object? That's why it should be there. That should be there. So when we create an object, definitely what is required? Class must be there. Otherwise we get name error. This is another academic level of differences we got it. So this is about what? Objects. Actually classes and objects are very parallel. So I will save this as it is in your location. I will keep it as it is in your location. Classes, oops, under that classes and object, separate place on the demand of Ganesh Verma, I will place it. So objects in this place. So objects is coming, differences between classes, and one bonus answer also coming. Right? This is about objects in classes. So did you understand this? Right. How to create objects in class? One class object I will create in another class. Like a normal variable only I will create. What is there? That is a very regular practice. Fine. So that is very simple point. Okay now. So next we will enter into, after this is destructor concept is also discussed. With this classes, objects fully we understand. Inside of it, constructors, destructors, done. Next concept is encapsulation and abstraction I will introduce. That is also very easiest topic. How to access our class data members and methods from one program to another program. How to provide some sort of security to it. That is the meaning of abstraction and encapsulation. Most easy. After that, most powerful concept is inheritance and polymorphism. These are all pair concepts. One cannot be there, other one. Class is there, object is not there, no meaning for that. Classes and objects are like a pair. Constructor, initialization of object. Methods for what? Performing operations. Destructor is for what? Deallocating the memory space. These are all parts of what? Classes. Next we'll go for what? Abstraction and encapsulation concept I will introduce. So even if I introduce, time is not sufficient. Tomorrow I will go for abstraction and encapsulation I will introduce. Right? We have to write object name in a class or no? No. So object, we have to write object name in a class or no? Class or no, class or not. That is the meaning. See, Ganesh Verma. Here, look at students. What is his doubt? Simple. Look at here, class, Seema, class, student 1. Student 1. What is the function he has? DEF, display 1. Display 1 of what? Self. So, this is called what? Display 1 function of which class? Student class. Student class. This is one thing. Class. What is the next one? Student 2. What is this asking? DEF, display 2. Display 2 of what? Self. This is called what? Print of. Print of display 2 of which class? Student 2 class. Student 2 class. So I understand his doubt. I hope he is asking this question. I hope so. I am understanding like this. I don't know what is his doubt actually. I understand his doubt. Create one object on any one of your choice. S1 is equal to student 1 you create. Anyone you create, student 1. Okay. What are you doing? S1 dot what? Display 1 you say. Display 1. Display 1. So this is called one example I am taking. Tested.py. Tested.py. So save it in related place. Let it be in objects only. I am saving it. Coming to this place, out of that CD objects. Okay. There you say py tester. What happens? Where it is saved in. Go to that. Go to the location of it. E colon 4 p.m. Oops. Under that object, you save it. Yeah. Now you execute. I got display 1. Now I understand his doubt. From this place of which class? I want to call this display. I hope you also can say display 1 is coming to this place or not. From there, I want to call this instance method of this class from line number 5. Can anybody can answer? No. If you look at like that, really it's very sad. How do you call? What is that? Of which class? Student 2. First understand, you are not reading the notes. This is called instance method. Of which class? So I must create an object of what? Student 2. Student 2. Student 2. I say S2 is equal to what? Student 2. What is this now? S2 dot. S2 dot what I should say? Display of what? 2. Display of 2. So see that student 2. Student 2. What is the function name? Display. Display. See that it is calling. Nothing is there. Very simple that is. So it's very easiest job. Right. So one function of one class is called by another function of another class. Create an object and then call it. If it is a static method, call with respect to class name. If it is a class level method, call with respect to class name. Already explained that kind of stuff. Okay. Ganesh Verma, are you okay? Right. Yes, Asif, very good. So Ganesh Verma, are you okay? So, sir, I did student pick demo.py program. When I execute command prompt, type imaginating encrypted code. Brahmani, I don't know how you typed it. You see once again any spelling mistakes are there because I was executed and shown you. I don't know what is the error you typed. I don't know. You just see once and check it once again and then do it. See our code once and study it and then do it. Right? What ma? That program, that program is, I hope it is in where? This places, classes and objects. So under classes and objects, what is the program? Student unpick program. So see this program. This is a program what we have. This is a program. Main program is there. This is the program what we have. Take care of it. Fine. Okay, tomorrow class will go for what? Data abstraction, data encapsulation. So first 1 hour will go for the concept and followed by program. Easy, that is easy. Right. Okay, Ganesh Verma. Right. So Okay, Brahmani, okay, over, ma. Irfan, line number 13, what is there, ma? Okay, that was explained now, Irfan. A pickle dot load of FP, pickle dot load of FP, pickle dot load of FP will give you what? The pickled object data, OBJ. OBJ is what type? Pickled data type object. Pickled type is what data I was pickled it student, which was present in which module? Student module. That was done already. That is done. Right. Fine. Right. Fine. So, okay, ma Brahmani, shall I close the meeting? Right. Shall we close the meeting? So this was executed already. Execute once, sir. Okay. So I'll execute once. I will execute once. Directly I'll go to this program. So PY, what is my program name? My program name is student unpick dot py. Student unpick dot py. Perfect. Already done. This is done. Brahmani, executed. Okay. Student pick demo. Student pick demo. Enter the student number. Say 777. Brahmani. Right. Marks is 55.55. Yes, sir. Do you want to insert another record? No. So student unpick program. Student unpick program. Brahmani data got it. Got it. Brahmani, okay? Right. Student data is not shown, ma. That is append mode, na. How can you see that, ma? How can you see that? This is called student data. You cannot see that is in what? Append mode. Why? It is used in which mode? Which mode? AB mode. Append mode or not? Here you see AB. AB means binary. Binary means what? Pixel format it is available. Right? So don't try to take this. Don't try to take this. By seeing this, where is Brahmani data? Is it there? Huh? Okay. So only name is visible. What about others? Other thing is not there. So if you tell your name, no problem. If you tell your account number, IFSC code and PIN number, that is a problem. Okay. Right. Anyhow, done. Enjoyed the class. So tomorrow class, I'll go for what? Encapsulation and abstraction. So, okay, students, done. Right. So tomorrow class, tell about a dump. I already explained, Ganesh Verma, read the notes. Fine. So load function, dump function, all those things explain. So if I go on taking like that, 2 years it will become to complete my Python. Definitely 2.5 years it will become. Okay, fine. So anyhow, tomorrow I'll go for encapsulation and abstraction. Thank you. Good day.